Here is a partial solution to the practice exam. Let's talk about the AI readiness dataset. We first merge disparate, messy datasets from different sources, then clean and standardize fields and formats. Next, we compute an AI readiness score that summarizes data quality, infrastructure, and governance. Finally, we interpret the score with ethical care, watching for bias, protecting privacy, and avoiding overclaiming, so decisions based on the score are responsible and fair. So how do we collect data? They come from multiple sources. Enrollment records come from our internal databases, giving a reliable roster. Satisfaction metrics are gathered with short surveys and live API hooks to capture responses. Academic papers on AI are harvested through a research endpoint for up-to-date findings through APIs. Throughout, we log sources, apply privacy controls, and track provenance so every dataset is auditable and compliant with regulations. There are many quality issues when we gather data from multiple sources. We often encounter 4 common data quality problems. For example, missing enrollment records create completeness gaps that can skew totals. Mixed formats like 4.2 FEFs and NA make aggregation and analysis difficult. Implausible entries, such as 0 students but 40 papers, signal errors or misalignment. Scraped reviews can introduce sampling bias because the sample may not represent the population. Identifying these helps us decide cleaning and validation steps. Let's look at this example. What does it do? Pause and think about it. We have a column called Average Satisfaction. We split the text by backslash and then take the first token and convert it to a float. In the next example, we use pandas to convert the column to numeric with errors coerced, so any non-numeric entries become missing values. These 2 steps transform messy X out of Y strings into clean numeric scores ready for analysis. Sometimes we have to remove invalid enrollment entries. We do this by first dropping rows where the students enrolled column is missing. In code, that uses the data frame method to remove missing values for that column. Next, filter the data frame to keep only rows where students enrolled is greater than 0. Together, these steps ensure every record has a valid, positive enrollment count. Note that this is only one way to do this, and there can be other methods to do the same. Some more steps and some less steps. If we are going to create a new feature, AI readiness, then we need to first normalize each metric using min-max scaling, BEST, which rescales values to a 0 to 1 range. Then we combine those 3 normalized metrics into a single AI readiness score, with 40% from enrollment, 30% from satisfaction, and 30% from AI papers. This weighted result gives a comparable number you can use to rank and track readiness across programs. There are ethical considerations in data collection. Rankings can hide important differences and produce misleading conclusions. Satisfaction scores often reflect who responds, not the whole population, so bias can enter the results. To be fair, researchers must be transparent about data sources, sampling, weighting, and assumptions. It is important to publish the full methodology and limitations so readers can judge how much trust to place in the findings. What does this code do? Pause the video and think about it. It takes a DF credits column and find the sum. It returns 1 value. Now if you apply sum to data frame, then you will get all row or column sums based on axis you use. What is the purpose of this code? Pause the video and think. We filter the data frame named DF to find computer science students with strong grades. The expression selects rows where the major column equals CS and the GPA column is greater than 3.7. The 2 conditions are combined with a bitwise operator, and each condition is wrapped in parentheses to ensure correct evaluation. Can you tell what this does? This code calculates the average GPA for each major by grouping records by major and taking the mean of the GPA column. The result is a list that pairs each major with its average GPA, letting you compare performance across departments. You can then sort or plot these averages to highlight differences and spot trends across majors. How about this code? This finds the highest GPA by taking the maximum value from the GPA column and save that as max GPA. Then filter the data frame to keep only rows where the GPA matches max GPA. This returns the student or students with the top score. Now let's talk about file processing. Let's say we have a bunch of books stored as text files in a folder called Books. First, import the operating system module with import OS. Then create book files using a list comprehension that loops over os.listdir of the books folder and keeps only names that end with .txt. This produces a list of text file names in books. Note it returns file names, not full paths. Use os.pathJoin if you need complete file paths before opening the files. Take a look at this function. This function takes a file name, opens the file in read mode with UTF-8 encoding, and assigns the file object to F inside a context manager. It returns the entire file contents as a single string, and the file is automatically closed when the block finishes. Call readBook with a file path to get its text. How about some tokenization? Tokenization prepares text for analysis. First, convert all characters to lowercase so terms like apple and apple match. Next, strip punctuation such as commas and periods. Then, split the clean text into individual word tokens. Finally, remove duplicate tokens and common stop words like the or and to focus on meaningful words for downstream tasks. Here we are trying to build a book index. Start by creating an empty dictionary to hold terms and their documents. For each book file, read the file and split its text into tokens using a tokenizer. Then add each token into the index, recording which book contains it. This produces an inverted index that maps words back to the documents where they appear. Let's talk about some data frame operations. Check the number of rows using the data frame's shape at index 0, which tells you how many records exist. Use the data frame's ISNA method followed by sum to count missing values per column and find data quality problems. Finally, call the course column's unique method to see how many distinct courses appear. These fast checks guide cleaning priorities and help you understand the dataset structure. Now, finding outliers is an important step in data management. Find Q1 by taking the 25th percentile of the students enrolled column using the data frame quantile method, and find Q3 by taking the 75th percentile the same way. The interquartile range, or IQR, is Q3 minus Q1, which measures the spread of the middle 50% of the enrollment data. To remove outliers, compute the lower bound as the first quartile minus 1.5 times the interquartile range, and the upper bound as the third quartile plus 1.5 times the interquartile range. Then filter the data frame to keep only rows where the students enrolled column value falls between the lower and upper bounds, inclusive. This removes extreme outliers while preserving the main distribution of enrollment values. So here is a function that we can use or pass as a lambda function. A function named categorize takes a numeric grade and returns one of three labels. If the grade is greater than or equal to 90, it returns high. If not, but the grade is at least 80, it returns medium. A good use of this function is to create a new feature that only contains high, medium, and low. Here are the key takeaways. Know how to analyze a problem, think of what data to collect, how and where to collect them, how to deal with messy and inconsistent data. Think about legal and ethical issues in data collection and data usage. Know how to use pandas method and string method to clean data, make data the same type, or convert a column from one data type to another. Learn how to analyze data, filter by a group, apply a function built-in or lambda, and aggregate data. Know how to find outliers using min-max scaling or z-values. Know about one-hot encoding, etc. Final advice. Preparing for a test is not memorization. It is the understanding. You have access to all function calls with cheat sheets. You just need to learn how to apply them properly. Happy studying and good luck.